Hey friends, welcome to my YouTube channel, and today I'm here and starting a new playlist for linked list in data structures. So as it is one of the important topic and most commonly asked in interviews, so that's why I'm going to start it, and we will make sure that we are getting all the approaches of all coding questions of linked list which are commonly asked in interviews. And I'm assuming that if you are looking these videos, if you're watching my videos, so you are aware about the arrays, because we can say that it is an upgraded version of array. Not same, but yeah, you should have knowledge about little bit knowledge about arrays as well. Okay, so I'm not covering array in my playlist. Like if you want, I should start from basics of array, so I can start this as well, but for now I am doing with the linked list. So I will make sure that we are covering all the questions, and in today's video we are going to learn that what actually linked list is and how it is implemented. Okay, so firstly we should know, like I'm not going to teach you each and everything about data structures, like what data structure is and what linked list is. We will just go through with the overview of linked list and we will directly jump to the coding questions. Okay, so starting with linked list is just basically a data structure which is used to store the data of same form. Like it can store integers, numbers, or any kind of data, but data should be of same type. Okay, and the thing is it also store a link. That's why it is called linked list. So let me explain how it works. It's basically store data inside a node. Okay, so this is a node, and in this node we have two parts. First one which store data, and second one which store reference to another node. Okay, so in this all the nodes are connected with a link. So here data will be there, and here reference will be there. Okay, so reference will be of any another node which is after that. Okay, so this reference will be pointed to another node which is here, and same like that this node will also store a data value and a reference. Okay, so inside there will be a data and there will be a reference. So reference will be of what? Of another node. Okay, so data can be anything. Like for now we are storing integers, so let's assume there is 4 stored inside it and there is 3 stored inside it. Okay, and this part will store a reference of next node. If there is not any another node, so it will just directly store null. So now it's node 1, it's node 2, and just need to make a structure. Okay, so how we can make a structure? For making a structure in C++, we just write struct and then the name of structure, what we want to call that. So generally we call it a node, so we are giving the name as a node. So this is a structure. Okay, so here we made a structure. Now inside this structure we have to initialize what we want to store inside that node. So inside that node we are storing two things. First one is we are storing variable which is integer type of variable, and we are giving the name data or value. Okay, and then we are storing a pointer which is pointing to the next node. Okay, so the name of pointer we are saying that next. Okay, so the name of pointer is next, and this is a pointer, so we just need to declare inside the structure as well that it is a pointer. Like here we initialize that the data is a type of integer, so here we also have to initialize that which kind of pointer it is. Okay, so which kind of data it is pointing. Like if it is pointing to the integer data, so it will initialize with the data type of int, but for now it is pointing to a whole node. Okay, so and which kind of node it is? It is a struct node which we are initializing here, which we are creating here. So we have to tell that it is a pointer to the next node, and node is a type of this node. Okay, struct node. Okay, I hope you are getting that why we are writing struct node, because this pointer is pointing to a node which is created with the help of a structure. So that's why we are writing this next is pointing to the node which is created here, struct node type of node. Okay, so that's why we have to initialize that which kind of node it is pointing. Okay, so this is how we create a structure. Okay, so we will see a code as well after that in system, but for now we are just going through with the basic of linked list. Okay, so we will complete it, we will finish it in one video only, and then after that we will be starting a coding questions of linked list. Okay, so we cannot directly jump to the coding because some of you might not aware about the linked list basics, so I am clearing it in a single video. Okay, so this is how we create a node. So now we need to initialize any node, a new node. So when we are making any new node or any kind of node, so we have to initialize its type as well. So its type is node. Okay, so we have given the name of that structure is node. Okay, so the type of that is node. So we are making a new node of node type. Okay, and then in C we write a new keyword, and then directly we can make our new. So with the help of this line we are creating a new node which is stored inside memory. Okay, and then we can store data inside this node. For suppose in first node we have 4, so we are assuming that it is our first node, and inside that we have to store 4 data. Okay, integer 4. So where we have to store 4, there is 2 part inside this node. First one is data and another one is reference pointer. Okay, so we have to store 4 inside data part. So we have to access the data part of new node, so we can access with the help of this pointer, and then we have to write that new node of data equals to 4. Okay, so what it will do, this line just initialized node inside memory. The name of that node is new node, and then this line is doing what? This line is just storing 4 integer inside the data part. Okay, and for now there is nothing inside the reference part or next pointer. Okay, so we have stored the 4 inside data part. Okay, now what we have to do is we just want to fill this part as well. Okay, so inside this what we can fill, if there is any node after that, so we have to fill it with the reference of next node. If there is nothing after that, so it will pointing to the null. Okay, null is means there is nothing after that. Okay, for now if there is nothing after that, so we will just initialize it with new node of which part? Reference part. And what is in reference? It is called next. We have given the name next. Okay, so new node of next is equals to null. It is pointing to nowhere. Okay, so we have created a one node. Like that we can make many nodes, and if there is any another node as well, so we can create another one as well with the help of this statement. And let's suppose we are making a next node, so node second node, we are giving the name, and then same syntax over there as well, new node. Okay, what we have to do is now we are just checking the logics only. Okay, how we access and how we can create, how we can add any data, how we can add links. So we are just taking that. Don't think about implementation. We will see whole implementation in coding part when we will do coding after that. Just understand that first. Okay, so now we have created a second node as well. Inside second node, same line, second node, what we have to do, we want to store 3 inside the data part, so we are accessing data and equals to 3. This is doing what? It is creating a node. This is creating a node, and where there is nothing stored inside it, then we have accessed the data part. Inside data there is 3 stored, and then what we will do is we will just initialize the second part as well. Okay, so then second part is second node of next, will be stored with null. Now we have created two nodes. Okay, so first one is this one 4 with pointing to the null, and second one is this one 3 pointing to the null. Now we have created two nodes. Okay, this is a new node. We can give the name first node to that. Okay, so now we have created two nodes. First one is second node and another one is first node. Okay, so now we want that we can link them like that. So what we need to do is we just need to give a reference of second node to the first node. Okay, so first node of reference part will be storing the reference of second node. What we have to do is we have to change this part of first node. Okay, so how we can change that? We can change that with the first node of next equals to null we have written here. So we can change it with first node of, we can change it with first node of next is pointing to what? It's pointing to node 2, which is second node. So we can write directly second node. So what this line will do is it will connect both the nodes with the link, and this link is here. This null will point to next node. We are making it here, so we can make it here as well. So it will point to next node, which is 3 with null. Okay, so now it is pointing this. This is how we implement nodes inside the linked list. Okay, so this is just the basic part, how we how we create a new node, or how we make structure. We can use class here as well, but there are so many students who do data structures in C. So that's why in C they use structure. So that's why I am just doing it with the help of structure only. In C++ you can use classes as well. This is how we created two nodes, and this list is ready. Okay, this is implemented inside a code in different types. Like we write a whole code and implementation code where we can initialize a separate function for inserting a new node, or deleting any node, or finding any node. We can do anything as we do inside the array. So if these values will be stored inside the array, how it looks like? See, it will look like that, 4 and 3. Okay, so this will be the array representation, or this will be the type how we can store these values inside the array. So what was the problem in arrays? When we can store the same things inside array, so why we need to use linked list? So the problem is, if we have initialized array with the size of 2 only, so we can store only 2 values inside it. But this limit is not inside the linked list. If we want that we want to store any other data inside it, so we just need to do what? We just need to do this line. We will create a new node, and then we will initialize the values of we will initialize both part of that node, and then we will directly link to the node 2 with node 3. Okay, so this is how linked list is we can say upgraded version. But everything has some pros and cons, so there is some cons as well. Let's see what are these. So in array we can directly access to third. How? Let's suppose the name of this is array, and we want to access the 3 which is inside a 1 index. So we can directly write that array of 1. It will give us directly 3 value. Okay, value of first node, first index, value of first index. But we cannot do the same with linked list. We cannot directly access 3. We have to traverse all the list, and then only we can do what? We can reach to the 3, and then we can access 3. Okay, we cannot directly access it with the help of index as we do inside the array. Okay.
Hello friends, let's start with code. It's a basic things that we write IO stream. Okay, and I'm not here to explain that why we write IO stream and all. Okay, I explained you code with the help of structure. So for now, I will be writing it with the help of classes. Okay, so firstly, I will make a class as I was making a struct node. So I am making a class node where I will be giving a data members. So data member was what? A data which was of integer type, and another one was pointer, pointer to the next. Okay, and this is a pointer, and which type of pointer it was? It was a node type of pointer. Okay, so we have initialized our class. Okay, so now our class is ready. So now we can make any node with the help of this node class. Okay, so now write the functionality of main, and inside main function we will be giving all the functionality what we want to do. What we will do is, in linked list we always have a head pointer. Okay, so head pointer is what? Which point to the head of the lists. Okay, so firstly we will create a head pointer. So this pointer will help us to point the list. Okay, so we can start our list from the head, and then we can traverse till last or till wherever we want. Okay, so initially we have nothing pointed in head, so that's why we have assigned it with null. Okay, so now what we can do is, we want to add some data inside the list. Let's suppose, assume we want to make a list, and list is here like that. We want to make a list like that: 2, then 3, then 4. Okay, so we want to make this list, and at the end there will be a null, which we have covered in lecture also. So firstly what we will do is, we will call add function, which will add the one inside list. Okay, and then we will do as well as we also have to update the head pointer, because if we will inserting a 1, so head will be at the place of starting. Okay, so always we have to pass head as well. Okay, then we will again add 2, and we will pass the head as well, because we also need a pointer that where our list is, from where our list is starting. And then again we will pass the head with 3 value, and then again we will pass our 4 value with head. Okay, so with the help of add, we can add a new node in our list. Okay, we can also use a loop here, like then we don't need to write add 4 times. We just directly can ask the number of nodes by user, and then we can run the loop that number of time. Okay, but here we are just looking for the implementation. We will not going to see all basic things. Okay, you can add here while loop as well, for asking the number of nodes from the user, and then you can implement your code accordingly. So for add, now we have to make a function add. So how we can make that? We are not returning anything in add function, and then what we are receiving in parameters. So firstly we are receiving a value, and then we are receiving a node type of pointer. Okay, so we are receiving a pointer which is head. So we have to define that which kind of pointer it is. We can take it as a reference as well. Okay, so then what we need to do is, we have to, now we got a value inside val, and we got head pointer as well. Now what we need to do, first part is, we have to create a node, as we have discussed in our lectures. So firstly we have to create a node. How we can create a node? We can create a node with node pointer and new node. Okay, and then new node. It was discussed in lecture as well. Okay, so now this line created a new node, and then we can assign the value inside this node. So how we can assign the value? We can write new node of next, new node of data equals to what? Value. So we can write here val, and then what we told, that if we are creating any node, so initially the next pointer will be assigned with the null. Okay, so what we will do, that next will be assigned to null. Okay, so one node is created in which data is assigned with value and next pointer is assigned with null. So this is a single node which is not connected with any other. So now we have to check that we have to insert it inside the list. And where is list? List is here. List is pointed with the help of head. Okay. Okay. So list is pointed with the help of head. Okay. So now what we can do is we have to check that if there is nothing inside head, if there is nothing inside head at the initial point of time when we are sending add one and head, that time there is nothing inside head. So what we will do is if head is null, so we will assign head with new node because that is first node. At the initial time, head is assigned to new node because one is the first node. So as visible inside this, head will be pointing to the first node always. Okay, we cannot change head. Head will be always pointing to the first node of the list. So initially we have to point head equals to new node, and then what? Then we can return from here. So this functionality will run only when head is null, and head when head is null when we are sending one. Okay, so if head is not null, then we have to write like if head is not null and there is nothing after and there is nothing and there is nothing after one. So then what we will do? We have to traverse one, we have to traverse head, and then we can find the last point and then we can add a new node. Okay. Then two will come with head. So now head is updated with one. Okay. So now what we need to do is we have to traverse the list and we have to go to the end of the list. So we cannot change head. So that's why we will be using a temporary pointer. So we have to create a temporary pointer. We are giving the name temp and that will be pointing to head. Now, like we cannot change our head. So we will traverse a list with the help of temp pointer. Okay. So we have to run a loop while temp of next is not equals to null. Okay. So while temp of next is not equal to null, till then it will traverse to the list and it will go temp equal to temp of next. Okay, this loop is going till end, and when there will be a point when temp of next is not equal to null, then it will stop executing. So what will be scenario here? Like at starting, temp is also pointing to the head. Okay, so temp is also pointing to the head. So loop will go till null. Okay, till temp of next is not equal to null. So initially in first iteration, it will check that temp of next is not equal to null. So temp of next is equal to null. So this condition will be failed and this will not go inside the while loop and it will directly uh, run the next line of the while loop. Okay, so the next line will be temp of next will be assigned with the temp of next will be assigned with the new node. Okay, so let's dry run this. So when two and head is coming, so firstly this line will create a new node. Okay, then it will assign the value with 2 and it will assign the next with null. Okay, so a single node is created with the help of this, and then its condition is checking if head is equal to null. So it will not true because head is initialized with 1, so it will not go inside that. Then this syntax will be called temporary variable will be assigned with the head, and then while loop go through, and then we can assign temp with temp of next equals to new node. Okay, so like that we can add 2 with the list, then 3 will come. Same situation will happen here. One new node will be created with the help of these lines. Okay, data will be assigned with the 3 and next will be assigned with the null. Then it will check that if head is null or not. If head is not null, then it will not go inside that and it will directly come here. Temp will be assigned, then temp will be used to go to the end of the list because we are adding a node in at the end. Okay, so then what we will do is we can do one firstly we will check that temp is pointing to the head, and firstly it will check that temp of next is equal to null or not. If it is not null, then it will go inside the loop and then it will update the temp. So initially it is not equal to null. Temp of next is not equal to null. Temp of next is 2. So it will update temp. Then temp will be then temp will be then temp will be pointing to the 2. Okay. So then temp will be pointing to the 2. Then it will again check that temp of next is equal to null or not. And after checking, it will know that the temp of next is equal to null. So that's mean it will not go inside the while loop, and while loop will be terminated here. And then temp of next will be assigned with the new node. So the new node which was created here, that will be assigned at the end of the list, temp of next. So temp of next will be new node. And what was the new node? 3. Okay. And 3 of next was the what? Null. So same like that, we have inserted a third as 3 as well. Then again for 4, it will also insert a 4, same like that. Okay. So the list we want to make is ready. Okay. So our list is ready. Okay. Now if you want to display our list, so then we can make a display function as well. So we can write display and then we have to pass head. So all the work will be done with the help of head pointer. Head is a very important pointer in linked list, which is always used to traverse or display or insert. Every time we need head. Okay. Head will be a pointing to the list. So now we will create a display function as well. So in display, it will just taking a head. Okay. So it is taking a head, and then what we have to do for displays, we have to go from here to here to here to here. Okay. We have to go from 1 to 2, then 2 to 3, then 3 to 4, and as well as we have to print them as well. Okay. So what we will do inside display function is we will just start traversing from head, but we cannot change head. So we need a temporary pointer for that. So what we will make a temporary variable for that, which will be pointing to the head, and then head will be at the same place, and we can traverse the list with the help of temp. Okay. So how we will traverse? So we will traverse with the help of same loop, like while temp of next is not equals to null, till then this loop will be run. Okay. So what we need to do then? Then in every node, we have to print the value of that temp. So initially temp is at the head. Temp is at the first point. So what we need to do is we need to print the value of temp. So it will print the value of temp, temp of data. Okay. And then what we need to do is after printing one, we have to send temp to the next node. Okay. Then we will send temp to the next node. And how temp will go to the next node? Temp equal to temp of next. That initially where temp was, go to the next of that. So initially it was at 1, go to the next of temp, and next of temp is what? 2. So then temp will updated with the 2. So now we have to print the temp of data. So again, this loop will run. Okay. So temp of data will be printed, and then temp will be updated to the next node. Okay. So again, same loop will go, and at the end, when temp will be at 4, then what will happen is temp of next is not equals to null. So temp of next is equal to null. So at that point, it will not going to print 4 because it will not go inside the while loop. Firstly, I will suggest you to stop the video here and just think the logic how you will handle that. Okay. So how you will handle that is print the last value outside the while loop. Okay. First way is that you can print the last value outside the loop, like that cout equal to temp of data. That will print the last value. Okay. So one way is like that. Another way is if you don't want to write any cout after the while loop. So what you can do is you can just do some little changes on your while loop termination condition. Okay. So what is your terminating condition of while loop? While loop terminating condition is temp of next is not equals to null. Okay. So what we will do here is we will just update it with temp is not equals to null. So now what will happen here? Temp is null? No, temp is 4. So it will go inside the while loop and it will print cout equal temp of data. So it will also print the 4 value and then temp will be updated with the next. So temp will be updated with the next. And what is temp of next now? Now temp of next is null. So temp will be updated with the null. Then it will check temp is null or not. So it will tell that temp is null. So now it will not go inside the while loop and that condition is also covered here. Okay. So now let's check the display function that it is giving the output or not. Oh, so sorry. Here it is a no type of pointer. Okay. So then see, it is giving output 1, 2, 3, and 4 because inside a list there is 4 nodes. Okay. And if we will print here, if we will run display here, so what it will print, let's see. So then display before inserting. Okay. So let's check. See, display before inserting. Then it is not printing anything because there was nothing inside the list that time. And if we will print after inserting 2 nodes, then it will give the output display after inserting 2 nodes. Let's do this first. Okay. See, display after inserting 2 nodes. Okay. So then it is only displaying 1 and 2. So our display function is also working fine. Our add function is also working fine. Okay. So we have implemented 2 functions. Okay. Now there is some more functions as well what we can perform, like we can add at the start, we can add at the end. So at the end it was the at end. We can also add at middle. We can also add at the specific position given by the user. Okay. And we can delete from any position. We can delete from middle, we can delete from start, and we can delete from end as well. So there are different functionality for every type of insertion and deletion. Okay. So for now we have implemented a function which is inserting at the end. We will see after that how we will be inserting the nodes at the start at a specific position, and then we will check that how we will delete the node from start, end, or from any specific position. Okay. And then these are also a coding question which are asked in interviews. Okay. The question of position is commonly asked in interviews, like there will be a specific position given to you and you have to insert the node at that position. Okay. We will see all the functions separately in further videos. So till now, I will just suggest you to, if you are able to implement this by yourself, so you can also make a logic to add at the front or delete from the end or delete from the start. Okay, then position 1 we will be doing after that. Okay. Yeah, so thank you. That's all for this lecture.